This video, we're going to talk about our second gas law, which is called the ideal gas law. And this differs from the combined gas law because it's more of a spot in time. It's just one thing at a time. So first, let's take a look at some more of these ratios. And this time, they're going to involve moles or molecules. Same thing. If you have pressure and temperature constants, and you're just looking at moles and volume, it is a direct relationship, which we learned already. Means that if one thing increases, so does the other. So if volume increases, so does moles. If moles decreases, so does volume. And then with pressure, we also have a direct relationship, so same thing. And then this brings us to what we call the ideal gas law. Now, the first thing you might notice is that there's no ones and twos here. There's a P, there's a V, there's a T, there's an N. There's also this R, which we'll talk about in just a second. But there's no ones and twos because this is not before and after. So the easiest way to tell which gas law you need is to see if you have two of some things. Like if you have two pressures or two volumes and you know there's a change, then you use the combined gas law. If there's no change, there's no two pressures or two volumes or two temperatures or whatever, then you don't need to use the combined gas law. You can use the ideal gas law. So the ideal gas law works the same basic way, except we also have something called the ideal gas constant. So we have pressure, and we have the same units for pressure, atmospheres, mmHg, kPa. We have volume. This time volume has to be in liters. Okay, we can't have milliliters, and that's because of the constant R. We have moles. We have temperature, which still must be in Kelvin. And we have the constant. The constant is dependent on pressure. So if you look at your periodic table, there is a little section for the ideal gas constant R on the back of your periodic table. Now they give you two numbers. So this is the one where when you have your pressure and atmospheres, you use this number, 0.0821. When you have your pressure in kPa, you use this number. And you might notice that the number for mmHg is not on here, so I would never ask you that on a test. But for practice purposes, it's 62.4 for mmHg. And you'll notice that the other units are the same. Liters is in all of them, moles is in all of them, and Kelvin is in all of them. I don't require that you know the units for R. You don't have to write them or anything. I just require that you know how to find out which R to use. So whatever your units for pressure are, you come here, look up the units for R, and pick that number. So let's do a couple problems. So here, if we have 1,500 milliliters, we just said this must be in liters, so I can convert that right away. And that's going to be my volume. Pressure, 624 mmHg. Temperature, again, needs to be in Kelvin here. So I'm going to convert this to Kelvin. Calculate the moles. So we start with our ideal gas law. And I'm going to solve right away for moles. So I'll divide by RT on both sides and get PV over RT equals N. And then all you have to do is plug them in. Pressure, 624. Volume, 1.5. R, we look up on our periodic table. Now we need the one for mmHg, which is the one I wrote in here. So I'm going to write 62.4. And I'm not going to bother with all the units for R. That's just a little too cumbersome. And then temperature is 299. So when we solve that, we get 0.05 moles. Let's try another one. This one is also looking for moles. Many of them will not be. This one has a 3-liter volume, temperature at 300, pressure at 1.5 atmospheres. So we're going to start by solving for N again. And plugging them in. So P is going to be 3.0. V, oh, whoops, that was V is 3.0. P is going to be 1.5. V is 3.0. R, we're going to look up on our periodic table, and this time we're looking for the atmospheres one. Atmospheres is right here, so I'm going to write this number, 0.0821. And our temperature is 300. So when we do out that math, we get 0.18 moles. Now I know both of these examples were moles, but you can definitely use this to solve for other things. It just happened to be these two problems were moles, but in class we'll practice others as well.